right. Spheres, set of all points in space equal distance from a given point. In other words, what is different about this than a circle?
It's 3D.
It's three-dimensional. That's it. So if I'm looking at a tennis ball, basketball, baseball, softball, all of those would be spheres. Now, the great circle, intersection of a sphere and a plane that contains the center of the sphere. In other words, if I took a baseball and cut it in half across the center, that flat part on top, that would be the great circle. Does that make sense?
Yes, sir.
All right. But it's got to go through the center in order to be the great circle. Hemisphere, if you cut the thing in half, you've got the two parts. Those are both hemispheres. All right. Here are what the diagrams look like. What do those little dotted lines mean?
That's radius.
That means it goes around, you can't see it. It's telling you that you've got a three-dimensional figure, but you can't see the back side of it. So get those copied down so we can't say we don't have diagrams to look at. All right. So you got what a sphere looks like on the top left. The great circle, again, is that flat part if you cut it in half. And then you would have the two hemispheres, top and bottom, for the last one. All right, then this next one you don't even really need to copy down. I'm just going to go through it real quick. All of the same stuff works now that the different circles. What does a radius do? Halfway across. Diameter. All the way across. The chord goes from one part on the sphere to another part on the sphere. So all that's the same. Nothing's going to change. The same rules still apply for that. All right, give that surface area. All right. First of all, what is surface area? Do we know that?
It's the area of the surface.
If you take a baseball, for example, or a softball, and the area around it, that would be surface area. What is the difference between this and the regular area of a circle?
The 4 is not there.
All you got to do is put 4 in front. It's the same as the area formula, which is just pi r squared. You put the 4 in front, now it's surface area. So for this first one, I'm going to go 4 pi 4 squared and get the second one. It gives me the diameter. I don't want diameter, I want the radius. So the radius in this case is what? 4.5, because I divide that diameter by 2. So I would say 4 pi and 4.5 squared to what? All right, any questions or problems on surface area? All you're doing is finding the radius, plug it into the 4 pi r squared formula. All right, if it were to say exact on this first one, I would do the 4 times 4 squared and get 64. Put pi behind it, there's your exact. I would do the same thing over here. I would do 4.5 squared times 4. Somebody tell me what that is.
Oh, what's that?
4.5 squared times 4. 81. So this would be 81 pi.
So you gotta like.
So that would
Do
be.
simply the number part. I would do this 4 times 4 squared. Do not do anything with the pi. Get your number answer, put pi behind it, and you got the exact. If it says exact, we're going to do it the same way we did before. All right, on these, it tells me what the surface area is and says find R. So I'm going to do the same thing I did when it was area. I'm going to say, well, here's my formula. I'm going to plug in
582 equals.
the 582 in place of the surface area.
You gonna divide by 4.
In this case, I'm going to divide by 4 pi and not just pi. Make sure you type that as a fraction, or you put the denominator part in parentheses.
Alright.
All right, so you get 46.3, but that equals r squared, so then what do I have to do for the last step?
Square.
I mean, y'all screw over.
I hope we're going to square root it.
6.8.
Should be close to 7.
6.8.
6.8. All right, so on this one, I'm going to say 4 pi r squared is my formula. 319 is the S. Divide by 4 pi. So what is that part?
25.4.
So 25.4 equals r squared. Square root that. Should be right at 5.
5 times 2.
You ain't got 10.
Oh. But that's right, radius, I forgot.
Ah, gotcha.
Diameter is 5 times 2, so my actual answer would be the 10 there.